I'm going to be taking you through how to graph reciprocal functions for Year 11 Spec, and this is chapter 15a. Reciprocal functions are functions of a form 1 over an original function. So for instance, if our original function is f of x equals 3 times root x, the reciprocal would be 1 over f of x, or 1 over 3 root x. If f of x is the function x squared over 24, the reciprocal would be 1 over this whole function. And remember, when we have 1 divided by x squared over 24, the 24 will come up the top and the x squared will end up on the denominator. Let's have a look at some key things that you need to remember and some handy hits about how to sketch an accurate graph of a reciprocal function. So here's the summary. To draw the reciprocal function, we need to know the following things. And I'll be doing this along with an example that I'm going to graph with you. So the first thing we need to know is the vertical asymptotes. If we have a function, the reciprocal function will have vertical asymptotes at the x-intercepts of the original function. In my diagram, I have an example where f of x is x minus 5, and I have the reciprocal function 1 over x minus 5 called g of x. We're going to sketch g of x. Notice our f of x intersects the x-axis at x equals 5, so that is where my g of x will have an asymptote drawn in by a dotted line. Intersections. So note that the two graphs, the original and the reciprocal, will intersect at f of x equals 1 and f of x equals minus 1, or y equals 1 and y equals negative 1. I can see my line y equals x minus 5 hits y equals 1 at the point 6,1 and also hits negative 1 at the point 4 minus 1. So this is where those functions will intersect. Next, I look for what direction my reciprocal function is moving in. So as f of x reaches infinity, my reciprocal function will tend towards 0. So we can see that x minus 5 goes towards positive infinity from 6 onwards. So my reciprocal would go down towards 0 from this point, x equals 6 onwards. And it's always on the same side on the x-axis. Next, as my function goes towards negative infinity, so x minus 5 tends to go towards negative infinity from x equals 4 all the way down to negative infinity on the x-axis, my reciprocal function will go towards 0. So from x equals 4 and everything smaller, my reciprocal will go towards 0 from below. Where my function f of x goes towards 0, my reciprocal will go towards infinity or negative infinity. So we can see it goes up towards my vertical asymptote between x is 5 and 6, and it goes down towards negative infinity between 4 and 5, where my original function tends to zoom into 0. The last thing is, when f of x has a maximum, my reciprocal will have a minimum. When f of x has a minimum, my reciprocal will have a maximum. As you can see here, there are no maximum minimum values in y equals x minus 5, so there are no maximum or minimum values in my reciprocal function. I also want to find the y-intercept. So notice the y-intercept of my original function was 0 minus 5. That means the y-intercept of my reciprocal function would be 0 and then 1 over minus 5. 1 over f of x, or 1 over x minus 5, cannot equal 0. So although there's a y-intercept at 0 minus 1/5, there is no x-intercept here. There is another asymptote along the x-axis. Okay, using the principles from what we just saw with the previous set of functions, we're going to sketch f of x and then sketch the reciprocal of this function on the same axis. Let's start by sketching f of x. F of x is the function 2 times x plus 1 times x minus 1. 1 over f of x would just be 1 over this function. Okay, let's graph the original first. First, we should find the x-intercept of my original function by letting y equals 0 or f of x equals 0. So I have 0 equals 2 times x plus 1 times x minus 1, and we know the zeros will occur at x equals minus 1 or x equals 1. I'm going to draw this function in red and mark in the points as we go through. For the y-intercept, we can just rearrange slightly. I'm going to expand everything. So I get 2x plus 1, x minus 1. If I expand that, I'll get 2x squared minus 2. I'm then going to let x equal 0 to find my y-intercept. And we can see that my y-intercept is at the point negative 2. I also know that f of x is a parabola. If it's 2x squared minus 2, the number in front of the x is a 2. That will mean it will open upwards or is concave up. It seems to be quite a narrow parabola that we've got here. Okay, once we've got those key points, I can start to find the reciprocal function. So, first thing is always asymptotes. They're the easiest to identify. This will have asymptotes at the x-intercepts of my original function. So x equals minus 1 and x equals 1 will both be asymptotes. Let's draw this with our dotted line. So my function will tend towards these asymptotes at some point. Secondly, my graph intersects the original graph at the point f of x equals minus 1 and f of x equals 1. Or y equals 1 and y equals minus 1 if you prefer. So I know the y-coordinate of the intersection. I need to find the x-coordinate. Using my parabola graph, I can just let y equals 1 and y equals minus 1 and solve to find x. If I have the 1, I'll have 1 equals 2x squared minus 2, plus the 2 to the other side, divide by 2 and take the square root. So I have two possible values here. X could be positive root 3 on 2 or negative root 3 on 2. For the minus 1, let's again move that negative 2 across by plussing 2. Divide by 2, I'll get x squared equals a half, or x equals plus or minus root half. So that means that these graphs are going to intersect a total of 4 times. Let's write out where. So the first point is negative root 3 on 2, and my y was 1. I also have positive root 3 on 2, with my y being 1 again. And then I have negative the square root of a half. My y value was minus 1, and I have the positive version of this. So positive square root of half minus 1. Okay, beautiful. The next step is to figure out where my reciprocal function tends to 0 and where it goes off into infinity. So I like to recall that my reciprocal function will always be on the same side as the x-axis as the original. It will go towards infinity when my original function goes to 0, and it will go towards 0 when my original function goes towards infinity. So I can see 2 points when f of x goes towards 0 above the x-axis. And I'll highlight these in yellow. So from about the point minus root 3 over 2 to minus 1 for x, and from x equals 1 to root 3 on 2, my reciprocal function tends towards infinity. So it goes up towards my asymptote. The reciprocal function always goes towards 0 when f of x tends to go towards infinity. So any x value greater than root 3 on 2, my reciprocal will go down towards the x-axis but not cross. And anywhere less than minus root 3 on 2, my reciprocal function will go down towards the x-axis but stay on the same side as my original function. The same applies with the negatives. One over f of x will go towards negative infinity when the original function goes towards 0 from below. So let's see where our original function goes towards 0 from below the x-axis. I can see in between minus 1 and x equals minus the square root of a half, my original function goes towards 0. I can also see that between x equals root a half and the point x equals 1, the original function again goes towards 0, so my reciprocal will tend towards negative infinity, again getting close but not touching my vertical asymptotes. Now when our original function goes towards more negative numbers, our reciprocal function will tend towards less negative numbers. So again, we should see that between x equals minus root a half and x equals root a half, my function gets a little bit less negative, and actually it would reach a maximum point. F of x has a minimum at y equals minus 2. So at that point, along my y-axis, the reciprocal will have a maximum. Remember, the x-coordinate will stay the same, so it will have a maximum at 0, and the y-coordinate becomes 1 over the value of my f of x function. My f of x function was negative 2, so my maximum for the reciprocal will become minus a half. Beautiful. That is your reciprocal function. So continue with 15a. I hope you've learned a little bit more about reciprocal functions.